Let's do some problems in logarithms. Okay, in high school, we learned that we can find logs of only positive numbers and not for negative numbers. That is true only if we are not willing to get into complex world. But if you are willing to get into the complex world, then we can figure out the log of minus x. Okay, so we are going to figure out what is log of minus x. Now minus x can be written as minus 1 times x, and this minus 1 can be written as cos pi plus I sin pi, because cos pi is minus 1, sin pi is 0, so it works out to minus 1 times x. Okay, now this cos pi plus I sin pi can also be written as x times e to the power of pi I. Okay, and now we follow log rules, right? So we take the log of both the sides. Log of minus x is equal to log of x e to the power of pi I. Okay, again log of x plus log of e to the power of pi I. Remember, when I'm writing log here, uh, let me mention it in general that in higher mathematics, even if we write only log, it is understood that we are talking of to the base e, although there is a separate notation for natural log, so that is ln is the same as writing log of e. For convenience, it may also be written as log. The context will specify whether we are talking of natural log or log to the base 10. Even if I miss out writing e in log ex, understand that it is to the base e. Okay, so now we know log and e cancel out each other. They are inverses of each other. So we end up with log e x plus pi I. Now it is periodic in nature. It is multi-valued function. So this can be written as log ex plus pi I plus 2n pi I. The period is 2n pi I, which means we can write it as log e of x plus pi I times 2n plus 1. So naturally, since we are taking the general form, we should write it as log e of minus x, capital L. Okay, so this is the expression for finding the logarithm of a negative number, negative real number. Okay, what about if we have a instead of a negative number, we have to find the log e of xi, that is a purely imaginary number. We don't have the real part of the complex number, we just have the imaginary number. So this we have to figure out what it is. X is equal to, or xi is equal to x times, that I can be written as cos pi by 2 plus I sin pi by 2. Now, what is cos pi by 2? It is 0. I sin pi by 2, sin pi by 2 is 1. So, I. So, xi. So, they are both equivalent. Okay. We know that cos pi by 2 plus I sin pi by 2 can be written as e to the power of pi I by 2. So, now we take the log of both the sides. Log of xi is equal to log to the base e of x e to the power of pi I by 2. Okay. Again, using the logarithm rules, we split it. Plus log e of e to the power of pi I by 2. Now, again, we can write this as log e and e, they are inverses of each other, they cancel out. So we end up with log e x plus pi I by, let's make it general, plus 2n pi I, which means this can be written as pi I log e x plus pi I times 2n plus half. Okay, so this is the log of a purely imaginary number. So we have seen for a negative number and we have seen for a purely imaginary number. Let's do some problems, right, based on this. So let's say we want to figure out the log to the base e of -1. What will this be? Remember, we have seen that log e of x is equal to 2n plus 1 pi I plus log e x. Now let's do the substitution. Log e of x, or rather -1, is equal to 2n plus 1 pi I plus log e of 1, right? Remember, minus x. So here x is 1, not -1. Okay, so this can be simplified to 2n plus 1 pi I plus 0. Log e of 1 is 0. So we end up with 2n plus 1 pi I. But we want only the principal value. So principal value would be when n equal to 0. So which means this will become 0, 1 will be remaining. So pi, so log e of -1 is equal to pi I. Okay. Now similarly, let's look at the log e of I is equal to what? Now we know log e of xi is equal to log ex plus I times 2n plus 1 by 2 pi. Okay, so let's do the substitution. Log e of, when will it be I? When x is 1, right? So this will become 1i. So here this will become log e of 1 plus I times 2n plus half pi, and log of 1 is 0, and when n equal to 0, log e of I would be equal to, this will disappear, we are left with pi I by 2. So this is equal to pi I by 2. Okay, interesting. Now let's look at the next problem. Let's say now we are not talking of purely imaginary. Let's say this is which problem? Fifth problem. Let's say we have to figure out the log of 1 plus I equal to what? Okay, so log e of x plus iy is equal to half of log x square plus y square plus I tan inverse of y by x. This we have seen in the previous session, right? So if you want to know how this came about, have a look at the previous video. Okay, so this is our formula. Let's apply that. Log e of 1 plus I. So here x equal to 1, y equal to 1. So when we apply it, it becomes log of x is 1, so 1 square, plus y is 1, so y square, plus I tan inverse of y is 1, x is 1. So we get 1 by log of 2 plus I tan inverse of 1. Now for what angle will tan be 1? That is what this means. We know that it is going to be log 2 plus I. This would be pi by 4. Tan 45 is equal to 1. Tan pi by 4, that is 45 degree, is equal to 1, because sine and cos are equal. Okay, so which means pi by 4 is equal to tan inverse of 1. Okay, but we also know that this is again going to be periodic. So let's make it periodic. So log of 2 plus 2n pi I plus I pi by 4. So now let's do the final step. Here I is common. So plus I times 2n pi plus pi by 4. So log to the base e of 1 plus I is equal to this. Okay. What will be the next one? Next is log to the base e of a plus bi by a minus bi. Right? And here, instead of just putting a question mark, I'll say that this is equal to 2I tan inverse of b by a. So which means this question becomes, prove that this is equal to this. Okay, don't get panicky. We know log e of a plus bi by a minus bi can be written as log e of a plus bi minus log to the base e of a minus bi. Logarithm rules. Okay, and we also know that log e of x plus iy is equal to 1 by 2 log of x square plus y square plus I tan inverse of y by x. So we apply this in both of these two cases. So our log e of a plus bi by a minus bi is equal to 1 by 2 log of a square plus b square plus I tan inverse of b by a minus again 1 by 2 log of a square plus b square minus I, but minus into minus, so this will become plus I tan inverse of b by a. So as you notice, this and this gets cancelled and we are left with I tan inverse of b by a plus I tan inverse of b by a, which means we have 2I tan inverse of b by a, which is what we had to show. 2I tan inverse of b by a. Okay, I think that's enough. Bye.